Hey guys, so we're going to get started in chapter 11, the last chapter for the school year. All right, so lesson 1 is broken up into 2 days. Basically, day 2 is just a day for you guys to do some review and practice. So the bulk of what I'm teaching will be taught today. All right, I have the setup of our vocabulary. Like I've been doing, I will post the blank notes and my answer key as well for you to take notes as you watch the video. All right, so let's get started with some vocabulary, some old terms and some new terms. First, we have circumference. So when we talk about the circumference, we're talking about the distance around a circle. All right, so we're talking about basically the perimeter, if you want to use a term that you're familiar with. The distance around the circle. When we talk about the distance around the shape, we're talking about the perimeter. So we're talking about the circumference of the circle, the distance around. Arc length, a portion of the circumference of a circle. Okay, so if we don't want to talk about the entire circumference, but we want to talk about a portion of that circumference, we're going to be talking about the length of arc AB. That's different than the measure of arc AB, which we talked about in the last chapter. We know the measure of this angle is equal to the measure of the central angle, right? The measure of the arc is equal to the measure of the central angle. But if we're talking about the length of the arc, we're talking about the portion of the circumference that this arc represents. All right, so here we have highlighted in red arc AB. So if we wanted to find the length of arc AB, we could use this equation, but I tend to use this one more, but I'll read both. This says the arc of length AB over 2 pi r is equal to the measure of arc AB over 360. Again, the formula I tend to use is the second one. The arc length of AB is equal to the measure of arc AB divided by 360 times 2 pi r. 2 pi r is our circumference formula. So basically, you're taking the fractional portion that this represents and then multiplying it by circumference, which I didn't write the formula for circumference above. I should have done that. So I'll go back now. All right, so circumference is either 2 pi r or circumference is pi times d. Okay. All right, and then finally we have radian. Now this is new. When we talk about a radian, all right, for a circle with radius r, the measure of an angle in standard position whose terminal side intercepts an arc of length r is 1 radian. So just like you have different ways of measuring length, right? You could measure a segment in inches, in centimeters. We have different units of measure. We have different units of measure for measuring an angle. Now, we are used to measuring in degrees. However, a radian is a different measurement of an angle. Okay, and we have some conversion factors here. First off, 1 radian is approximately 57.3 degrees. Okay, or that's also 1 radian is equal to 180 divided by pi. Okay, and we're going to be using that conversion factor. Or you can also have 180 degrees is equal to pi radians. Okay, so that is the vocabulary. Let me get the first problem set up for us, so give me just a minute. Okay, so the first problem we're going to look at from your notes, example 1. All right, it says the diameter of a circle with a circumference of 10 inches. All right, so what it's asking us to find is what is the diameter of a circle with a circumference of 10 inches? So start with the information you're given. You're given circumference is equal to 10 inches. You're trying to find the diameter. That's our unknown. Okay, so typically what I do is I think about, all right, if I know the circumference is 10 inches, think about circumference formula. Okay, circumference of a circle is equal to 2 pi r, or circumference of a circle is equal to pi times d. Now, you can use either one of those formulas. However, since I'm trying to solve for the diameter, I'm going to focus in on this one here. If you substitute in what you know, circumference is 10, so I'm going to substitute that in for C. That'll leave you with an equation where you can solve for the diameter. All right, I'm going to divide both sides by pi. So the diameter is equal to 10 divided by pi. Now the directions don't ask you to round to the nearest tenth or hundredth. So what we're going to do is just leave our answer in terms of pi because that's the exact answer. If we were to plug it into our calculator and do the division, we'd then be given an approximation, and it doesn't ask for an approximation, so always give exact. Oh, and I didn't put my units, I should include that. It was inches for circumference, so the diameter is 10 divided by pi inches. All right, that's problem number 1. So for problem number 2, let's see if I can fit one more problem up here before I have to erase. For problem number 2, it says, we want to find the circumference of a circle with a radius of 3 centimeters. Okay, so we're given the radius is equal to 3 centimeters. We're trying to find circumference. Now, if you wanted to draw a diagram for this one, you could, right? You could have a circle with a radius of 3 inches. Okay, the diagram isn't necessary. What I want to do again is use one of the circumference formulas. This time I'm going to use 2 pi r because I'm given radius. So circumference is equal to 2 pi r. You're going to plug in the radius of 3. Circumference is equal to 2 times pi times 3. Multiply the 2 and the 3 together. So circumference is equal to 6 pi centimeters. Again, it doesn't ask for an approximated answer, so give exact answers, which means you're going to leave pi as part of your answer. Okay, let me erase. All right, problem number 3. So for problem number 3, it's asked us for the radius of a circle with a circumference of 8 feet. So what do you know? You know the circumference is 8 feet. You're trying to find the radius. Write down your circumference formula, 2 pi r, or pi times d. Since I want to know the radius, that's my unknown, I know the circumference is 8, so 8 is equal to 2 pi r. Divide both sides by 2 pi to get r by itself. Eight divided by 2 is going to be 4. The pi is still down that denominator, so 4 divided by pi equals r. Again, doesn't ask for an approximation, so you're going to leave your answer, and I'm going to rewrite it so I can write my units. It's 4 divided by pi feet. Right. And problem number 4. For problem number 4, it asks you to find the circumference of a circle with a diameter of 2.4 meters. Okay, so you know the diameter is 2.4 meters. You want to find the circumference. So write down whichever circumference formula you want to use, either 2 pi r or pi times d. The reason I'm choosing pi times d is because you were given the diameter. So now I have circumference is equal to pi times 2.4. So your answer is the circumference is 2.4 pi meters. Okay. All right, let me erase and get started for the next, or get ready for the next part. So now we're going to move on and talk about arc length. Hopefully what I just did was review. You guys have seen circumference formula in previous math courses, but you may not have seen arc length yet. Okay, so again, when we talk about arc length, arc length AB is going to equal the measure of arc AB over 360, because there's 360 degrees in the whole circle, so I want to know what fractional part the given arc represents, and then times 2 pi r, or times circumference. Okay, so and we use AB, but it could be different letters. It doesn't have to be AB, but I think in your notes, your diagram, yep, A, B, and P. Okay. So, the example in your notes says find the arc length of AC, and the diagram that's given, this is the example in your notes. The diagram that's given looks like this, where we have a circle, it's circle B, and we're given a central angle is 70 degrees, and my radius is 3 inches. And then you're given AC. And the problem asks you to find arc length AC. Okay. So I'm not asked to find the circumference. I don't want to know the whole circumference. All I want to know is a part of the circumference. I want to know what is this part of the circumference from A to C, arc length AC. All right, so I need to know what fractional part this represents of the whole circle. Well, if there are 360 degrees in a full circle, but this is 70 degrees, right? The central angle and the arc measure are equal to each other. So this is 70 degrees. I'm going to take 70 over 360, and that's going to give me the fractional part. Okay, so it's going to equal 70 over 360. And then once I know the fractional part that represents, then I multiply by the circumference. So then times 2 pi radius, which in this case is 3. Okay. I'm going to simplify 70 over 360, just knock off the zeros and make it 7 over 36. Times, multiply the 2 and the 3 together to get 6 pi. Now you could multiply the 7 and the 6 together and make one fraction, or I like to cross simplify, make the numbers easier to work with. So 6 goes into 6 once, 6 goes into 36 6 times. So now I'm left with 7 pi in the numerator over 6 in the denominator. All right, and my units is inches. And that would be your answer. And the next example, we're going to talk about converting between degrees and radians to degrees. So remember, radian is another measure for an angle in a circle. Okay. So the conversion factors that we're going to use are, and they're in your notes, I have them highlighted if you look at my answers, pi radian over 180. Or I'm going to use 180 degrees over pi radians. Okay, so for the example that are given in your notes, example 1 wants us to convert 60 degrees to radians. So you just have to multiply by one of the conversion factors. Now, you might start thinking maybe about science class when you guys convert units. You always want the units to be diagonal from each other, one numerator, one denominator, so that the units can cancel. So if I write 60 degrees as a fraction, it would be 60 degrees over 1. And if I want to cancel degrees, that means I need degrees in the denominator so that the degrees can cancel when I multiply by my conversion factor. So which one of these conversion factors has the degrees in the denominator? This one here. So that's how I know that I'm going to pick this conversion factor rather than that. So I'm going to multiply by pi radians over 180 degrees. Because now I can see that my degrees will cancel, and I'm going to be left with 60 pi radians over 180. Now I still have to simplify, and if you want, moving forward, you can cross simplify before multiplying, but since it was the first one, I didn't do that. So now I need to simplify 60 over 180. Well, to quickly simplify, you can at least start by knocking the zeros off and make it 6 over 18. And then what is a common factor between 6 and 18? 6 is a common factor. 6 goes into 6 once. 6 goes into 18 3 times. So then you're going to be left with pi radians over 3 radians. And that would be your answer. Okay. We'll do one more, but going the opposite direction. So now I want to convert from radians to degrees. So example 2, we want to convert from 5 pi over 6 radians to degrees. So the first step, again, is deciding which conversion factor to multiply by. Remember, you want your units to cancel so you can convert from one unit to another. So let me write this down again. You have 5 pi radians over 6. Marker's kind of dying on me. Okay, and I need to multiply by one of these two conversion factors. And since I want my radians to cancel, because I'm trying to go to degrees, that means I want the radians in the denominator. So that's how I know I'm going to multiply by 180 degrees over pi radians. Okay, so the pi radians cancels. So now you have 5 times 180 divided by 6. Okay, and you can again cross simplify. You can multiply the 5 times 180 and then simplify. Okay, but when you cross simplify and then multiply, you're going to be left with 150 degrees. All right. So that's it, guys. That's the whole lesson for day 1 of 11.1. You're going to try some homework problems, and then tomorrow will be a day of review and practice for you. All right, so check out Google Classroom. Make sure to read the entire post with all the announcements. Jump onto the online textbook and do your homework, and I'll see you back here tomorrow. Bye.